Hi, welcome to this session on topic of combinations of data sufficiency type of questions for as part of your video series for GMAT quantitative reasoning section preparation. So today's topic is combinations. There are two types of problems in the GMAT quantitative reasoning section. One is your problem solving, where you have one question and 5 answer options which you have to select the one which suits the best, and you have the data sufficiency type of questions where you're given one question and 2 statements. You have to check whether the information given is enough to answer the question in the given question. And today we will be looking at data sufficiency type of questions for the topic of combinations. Let's begin. So for any data sufficiency type of question, these are the standard answer options, 5 answer options, which answer option A will be when statement 1 alone is sufficient to answer the question, but statement 2 alone is not sufficient to answer the question. And answer option B is when statement 2 alone is sufficient, but statement 1 alone is not sufficient to answer the question. Answer option C is when both statements together are sufficient, but neither statement alone is sufficient to answer the question. Answer option D is when each statement alone is sufficient to answer the question. And answer option E is when statements 1 and 2 together are not sufficient to answer the question. Let's begin. Let's look at the first question now. The question says, in how many ways can 4 students out of n students be selected to represent the school in a competition? Okay. Statement 1 says if there were 3 more students, the number of ways of selecting 4 students would be 840. So statement 1, if there are 3 more students, that means there were n students given. Now if there were 3 more, that means if there were n plus 3 students in total, the number of ways of selecting 4 students, then that will be NC3 C4. Selection is C, that is combination, which is equals to 840. So from here you can easily calculate the value of n. So they are asking in how many ways 4 students out of n students can be selected to represent the school. You need what is NC4 equal to. For that, all you need to know is what n is, and from this you can solve for n easily. You don't need to do the calculation, but in case you want to check, you can see that n plus 3 into n plus 2 plus n into n into n plus 1 into n into n minus 1 and so on, divided by 4 factorial into n minus n plus 3 minus 4 factorial, that is n minus 1 factorial. So you can cancel out everything from here to here and you will be left with an equation in just single variable. And you can, by factorizing 840 into 4 factorial, you can check what n value is. Okay, that is how you have to go about if you have to calculate, but here you don't need to calculate, so you can leave it at that and just say that this information is sufficient to answer the question. Now the second statement says that if there are 3 less students, that is students were total n minus 3 less students, the number of ways of selecting 4 students would be 360. So here you will say C4 is equals to 360. From here also you can easily calculate n by making such a expression. Then you will be able to answer what is NC4 very easily. Therefore this is also sufficient to answer your question. So the statement 1 was also sufficient and statement 2 is also sufficient. Therefore answer option is D, when statement 1 alone and 2 alone are sufficient to answer the question. D is your answer, option D. Let's look at the next question now. There are some boys and girls present in a class apart from the teacher, and the teacher decides to choose 2 students for a certain experiment. In how many ways can she choose a boy and a girl for the same? Okay. So the first statement is telling us that the number of boys, let B be the number of boys, is 20% less than the number of girls, that is 1 minus 20 by 100 into the number of girls, let's say it is G, which is 1 minus 0.2, which is equals to 0.8 G. B is equals to 0.8 G, but still we don't know what B is and what G is. Both are still unknown, so you cannot calculate in how many ways she can choose a boy and a girl. You need to know the number of boys and the number of girls, which is not sufficient because from here you do not get any information of what B is and what G is. The second statement says number of girls is 25% more than that of number of boys in the class. So G is equals to 1 plus 25 by 100 into B, which is equals to 1.25B. Here again it's the same, you're getting an equation relating G and B, but they are not giving us any information for calculation of exact value of B and G. So that's also not sufficient. Now when you look at statement 1 plus statement 2 together, you get that B is equals to 0.8G in statement 1, and in statement 2 you get G is equals to 1.25B. This is nothing but the same thing. If you say B from here will be equal to G divided by 1.25, which is 100 by 125 times G, which is 25 5s, 25 4s, 4 by 5 G is nothing but 0.8 of G. 5 into 0.5 is 40. So you get the same thing. So together also they are not sufficient to answer the question. So when statements together also cannot answer the question, answer option becomes E. When both the statements together are also not sufficient to answer the question. So E is our answer option. Let's move to the next question now. 5 persons sat next to each other around a circle table to play cards. Did Grace sit next to Bill? They are sitting around a circular table and there are 5 people. So they are asking, did Grace sit next to Bill? Dora sat next to Ethel and Carl. So the only way that is possible is when Dora is sitting here and one side is Ethel and one side is Carl, or you can say Dora is sitting here and one side will be Carl and one side will be Ethel. But in either way you are left with only Grace and Bill. So they will be sitting next to each other. They will be sitting in these empty seats that are left after arranging Dora, Carl and Ethel. So therefore statement 1, this was our statement 1, is definitely sufficient to answer the question. That yes, Grace and Bill did sit next to each other. Looking at this next statement, statement 2, Grace sat next to Carl. Okay, they're saying that Grace sat next to Carl. So there are 3 more seats left. So when we are saying that, we are asking whether Bill sat next to Grace. So Bill can be here, here or here. So therefore you cannot definitely say whether Bill is next to Grace or not. Therefore this is not sufficient to answer the question. So therefore answer option is A. When one statement 1 alone is sufficient to answer the question, but statement 2 alone is not sufficient to answer the question. Let's move to the next question now. When cleaning her house, Carlotta discovered an old box of candles and figurines, each of which is unique. She wants to display the items on a shelf. How many different ways can she place the items in a row on the shelf if she alternates between candles and figurines? If only the figurines were lined up, 40,320 different arrangements would be possible. Okay, she's altering candles and figurines. Let's say C is the number of candles and F is the number of figurines. So what does statement 1 tell us? Statement 1 is telling us if only the figurines were lined up. So that means it will be in how many ways? It will be in 5 F factorial ways, which is equals to 40320. By factorizing this, we can easily calculate the number of figurines F, but C is still unknown, so you cannot tell in how many different ways does she place the items in a row. That cannot be answered because you don't know what C is. Therefore this is insufficient. Let's see second statement. Second statement tells us Carlotta has 1 more candle than the figurine. So C is equals to F plus 1. From just this information, we do not know what C is or what F is. Therefore this is also insufficient to answer the question. When you combine statement 1 and statement 2 together, you see that from statement 1 you can find F, and you know from statement 2 C is equals to F plus 1. So you will easily be able to calculate what C is. Therefore this information together will be sufficient to answer your question. Therefore answer is answer option C. When statement 1 alone is not sufficient, statement 2 alone is not sufficient, but statement 1 plus 2 together is sufficient to answer the question. Let's move to the next question now. There are n people standing on line L. What is the value of n? Statement 1 says if one more person was standing on L, the number of different ways to arrange the people standing on L would be 5040. If 2 fewer people were standing on line L, the number of ways to arrange the people standing on line L would be 24. There are n number of people, they want to find out what n is, n number of people standing in the line. Okay, statement 1 says that if there were one more person standing, that means if it was n plus 1 was the total number of people, the number of ways to arrange the people would be standing on the line would be 5040. So, n plus 1 factorial is equals to 5040. From here easily you can calculate what n is. You can say that n plus 1 factorial is equals to 5040, which is nothing but 10 into 504, which is equals to 10 into 504 into 4 is 4 ones are 4, 5, 4 2s are 8, 9, 10, 4 6 are 24, which is equals to 10 into 4 into 6 into 21, which is 3 into 7. Into 10 can be written as 2 into 5. So, you can write this as 1 into 2 into 3 into 4 into, there is a 5, 5 into 6 into 7. So, therefore, 5040 is nothing but 7 factorial. So, n plus 1 is 7. So, n comes out to be 6. Okay, now let us see what statement. So, this was sufficient to answer. You do not need to make this calculations. I only made it for illustration purposes. You can just from directly seeing this, you can say that yes, there is one equation and one variable. So, it is sufficient to answer the question. And the second statement says that if two fewer people are standing on the line L, the number of ways to arrange people on the line would be 24. That means if it is n minus 2 factorial would be equals to 24. 24 is nothing but 4 factorial. So, therefore, n is equals to 4 plus 2, which is equals to 6. Again, this is information is sufficient to answer the question. Therefore, answer is answer option D, when each statement alone is sufficient to answer the question. Let us move to the next question now. A room contains exactly n people, out of which exactly half are men and half are women. What is the value of n? First statement says if all men present in the room are introduced to each other only exactly once, such that every man is introduced to every other man one time only, then the total number of introductions among men will be 10. And second statement says that if each woman present in the room is introduced to each of the men present exactly once, such that every woman is introduced to every man present only and not to any woman, then the total number of introductions thus will be 25. Okay, for the first statement, you can say that the men present in the room, let us say that it is equals to m, okay. So, when each is introduced to the other exactly once, what will it be? It will be m minus 1. The first person will be introduced to m minus 1 different people, then the next person will be introduced to m minus 2 people, plus so on so forth. And you will see m minus 3 until it becomes 1, so on so forth. This is equals to 10. 10 is equals to 1 plus 2 plus 3, 3, 3, 6 plus 4. Therefore, m minus 1 is equals to 4, which means that number of men are equal to 5, and they are saying that exactly half are men and exactly half are women. So, therefore, number of women, let us say W will also be equal to 5, and the total, that is n, will be come out as 5 plus 5, which is equals to 10. Therefore, this information is sufficient to answer the question. Let us see statement 2. Statement 2 is if each woman present in the room is introduced to each of the men present exactly once, such that every woman is introduced to every man present only and not to any woman, then the total number of introductions thus will be 25. So, each woman is introduced only to a man. So, each woman, there are W women and there are M men. Actually, they are equal, W is equals to M. But anyway, each of the women will be introduced to the man, each of the man exactly once will be M. So, you will have, and you have W women. So, each of this woman is shaking hands, introduced M times. So, into W, that is nothing but M square, which is because W is equals to M is equals to 25. So, M comes out to be 5, which is equals to N. Therefore, total N comes out to be 10. Again, this information was sufficient to answer the question. Therefore, answer is answer option D, when each statement alone is sufficient to answer the question. Let us look at the next question now. In a class, teacher decides to choose 2 students for a certain experiment. Out of the boys and the girls present, In how many ways can the teacher choose 2 boys for the same? Statement 1 is telling us number of boys is 20% less than number of girls in the class. So, let us say number of boys is equals to B, it is equals to 20, it is 20% less, that is 1 minus 20 by 100 into the number of girls, which is G, which is equals to 1 minus 0.2 is 0.8 G. So, you know nothing about the value of G, so you cannot comment on the value of B either. So, this information is not sufficient to find out the number of ways that the teacher can choose 2 boys. Okay, so this is clearly insufficient. Now, let us look at statement 2. In statement 2, the number of girls is 3 more than the number of boys in the class. So, G plus 3. Again, you know nothing about G, so you cannot calculate the way teacher chose 2 boys. So, this is also insufficient to answer the question. Let us see now statement 1 plus statement 2. Here B is equals to 0.8 G and here G is equals to B plus 3. If you do that, G, if you substitute the value of G over here, from here to here, you will get B is equals to 0.8 into B plus 3, which is equals to B minus B is equals to 0.8 B plus 2.4. So, taking 0.8 B to this side, you will have B minus 0.8 B, that is 0.2 B is equals to 2.4, which will cancel out 12 times. So, B is 12. So, you can easily say that the number of ways the teacher chose 2 boys will be 12C2. Therefore, together these are sufficient to answer the question. So, the answer is answer option C. When statement 1 alone is not sufficient to answer the question, statement 2 alone is not sufficient to answer the question, but statement 1 plus 2 together can answer the question. Let us move to the next question now. 3 members are selected from a group of X members, then what is the value of X? If team of 3 members is selected from the group of X members, then 30 different combinations of 3 members can be formed with 2 specific members never being together on the team. And statement 2 says there are total of 35 ways to make team of 3 members out of team of X members. So, the first statement, looking at the first statement, we have that team of 3 is to be selected, then there will be 30 different combinations of 3 members that can be formed with 2 specific members never being together. So, you can do this by the method of elimination. First, let us take, if there are only 3 members selected from the total of X, then that will be in XC3 ways. Now, you remove the number of combinations, teams formed having 2 specific members together. The 2 specific members, if you are already selected, you are left with X minus 2 people, out of which if you have to select a team of 3 people, you are only left to select 1 person because 2 are already selected. So, this will be equal to 30. It is X by C3 is X into X minus 1 into X minus 2 into X minus 3 factorial. You can write it X minus 3 into X minus 4 into so on up till 1, or X minus 3 factorial is the same thing. Divided by 3 factorial into X minus 3 factorial. This gets cancelled and you have minus X minus 2C1 is equals to X minus 2 is equals to 30, which 3 factorial is nothing but 6. By taking LCM, here you will be left with, and taking X minus 2 also common out, you will have X minus 2 into X into X minus 1 is X square minus X, LCM taken as 6, and here you have minus 1, so it will be minus 6, which is equals to 30. So, X square minus X minus 6 can be factorized as X minus 3 into X plus 2 is equals to 6 into 30, which is equals to 180. Now, you have this X plus 2 into X minus 3 into X minus 180, which is equals to 9 into 20, which is 3 into 3 into 4 into 5. Or you can write this as 9 into 4 into 5. Then you can say that X plus 2 is equals to 9. So, X is equals to 7. Therefore, X minus 3 will be equals to 7 minus 3 is 4 and X minus 2 will be equals to 5. So, 9 into 4 into 5, this will satisfy that X is equals to 7. Therefore, this is sufficient. You just need to find the value of X. Therefore, this statement 1 alone is sufficient to answer the question. Now, let us look at statement 2. It says that there are total of 35 ways to make 3 members out of x members. So, they are saying 𝗳𝐶3 is equals to 35. Again, you can write x into x minus 1 into x minus 2 into x minus 3 factorial divided by 3 factorial into x minus 3 factorial is equals to 35. This gets cancelled. It says that x minus 1 into x minus 1 into x minus 2 is equals to 5 into 7 into 6. Therefore, you have that x is equals to the biggest number there, that is 7. So, this is also sufficient on its own to answer the question. So, the answer is D, option D, which means that statement 1 alone and statement 2 alone are both sufficient to answer the question. So, those were some sample questions on the topic of combinations for the data sufficiency type of questions. Hope they were clear. Thanks for watching.